So we're going to talk about the solution process for the method of joints. What I do is I'd refer to your book, and as you start looking at the examples and start looking at things, you'll notice that, yeah, there's a process that's involved. The method of joints is a fairly long, fairly tedious process, okay? Once you get the process down, people like it because it's very repetitive, okay? And if you are good at solving equilibrium equations, it gets very, like I say, tedious, but it's very repetitive, okay? So the method of joints process. I'm going to outline maybe you could say a 4-step process or even a 5-step process. But the first thing that I would do is tell you, and this goes back to earlier work, is we have to solve the support reactions. Okay? The truss is, invariably probably going to be supported by a pin and a roller. Okay? You saw some of that maybe in the first test or whatever, earlier chapters. Maybe it was, maybe you had to solve support reactions for a beam. But I already said that a truss is no more than just a big beam. Okay? So you got to solve the support reactions. You got to do that correctly, because if you don't do it correctly, everything you're going to do for the method of joints and truss analysis from this point onward is just no good. Okay? The second thing, or maybe a thing that I throw along with this, is a concept of what I call the big picture. I like, as you're doing these problems, I like, you to, for every method of joints problem you do, to create a big picture of the truss. And I mean, maybe take up a half a page or maybe even a whole page with nothing but a picture of the truss. This is after the reactions have been solved, so that you have a picture of the truss, a big picture with the reactions, with the forces on it, so that when you're going through and doing your solution, that you can go back and say, oh, this member has this force on it. It's almost like your answer sheet, okay? That you can go through and say, okay, I'm keeping track of everything that I'm doing answer-wise on this big picture. So I would really recommend this. The worst thing that I see people do is they try to do the whole problem in a real small space on a page, and you'll never be able to follow it. These problems might take 2 sides of a sheet of paper. It might even, that's in addition to your big picture. So you might be thinking, hey, I'm going to take 2 or 3 pages to do a problem. All right? So big picture for me is important. After the big picture, you're going to draw free body diagram of the joints, or one joint at a time. The joint that you start at is going to be a joint, and this will become fairly obvious to you, but it's going to be a joint that only has 2 unknowns in it. Okay? If you got a joint that has 6 unknowns at it, and you try to start there, you just got too many unknowns. Okay? Remember, a joint is a concurrent force system in and of itself. When you draw the free body of a joint, you got the forces coming into that joint. Okay? So how many equations of equilibrium are you going to be utilizing when you get to a joint? How many? How many equations? Only 2. Only force equations. So here's your joint, and this is your free body, and you've got everything coming in a free body. There's no reason to write a moment equation, because where are you going to write a moment equation? Here's your joint.
In the center of it?
Well, if you write it in the center of it, everything cancels out, right? Because it's concurrent. So the only 2 equations you have are sum of forces in the x, sum of forces in the y. All right? 4th step, you got a free body of your joint. Write your equilibrium equations. And again, like I said, this means sum of forces in the x equals 0, sum of forces in the y equals 0. Okay? There's no reason to write a moment equation because it's not going to result in anything. The fifth step is solve your equilibrium equations. Put your answers on the big picture. And then, best of all, flip-flop, which that's a technical term, flip-flop. To me, what flip-flop means is as soon, and we had this up here before, but as soon, like say I'm down here at joint A, I've got a member AB. As soon as I know joint A is 500 pounds going that way, what can I automatically do? I can take this, move the 500 down here, and it goes the other way. Okay? Once you solve for AB down at joint A, AB is solved for down at joint B, and it's the same magnitude, you just bring it over. All right? So that, to me, that's what flip-flop is. And after you do that, you move on. You move on to another joint, and you solve another joint. Okay? So that means draw a free body, write the equations, solve, put the answers on the big picture, flip-flop, and away you go. Okay? And that's the solution process.